So Dr. Quantum's video, I find massively entertaining, right? So the the thing with electrons, right? We know from that double slit experiment that we can think of electrons as waves, and that seems weird to think about a thing as a wave, right? But light is a wave, we know that, right? Energy can be waves, gravity is a wave. Well, electrons we can view at waves. Einstein actually kind of figured out with light that sometimes things have both wave particle and particle property. Actually, everything has both wave particle and particle property, right? So like light can diffuse the way that we saw electrons diffusing, but light can do what's called the photoelectric effect, which is kind of cool if you want to look into that a little bit. We're not going to spend a lot of time on it. But electrons, we know from like electricity, can also behave as particles. So our older models of the atom, and the way we usually draw it is an electron's a little particle zipping around in a circle. But as we mature, we find out that, a lot of things we learned when we were little, like Columbus thought the world was flat and discovered America and no one else had been there, no Europeans. Right? We find out things are not true, right? Teachers lie to us all the time. So lies by simplification. So the actual view of an electron is pretty complicated, and that's what this thing is going to get into today. So when we are thinking about electrons, instead of thinking about them as a particle, following a certain path, we want to think about them as a cloud that kind of takes up an amount of space. There are two people that are kind of cool with these ideas. Heisenberg is one of them. Might guess that he's German, right? That's a little German sounding. If you're a Breaking Bad fan, you recognize that name. And he said you can't really know exactly where an electron is and where it's going. There's a limit to how much we can know. The more we know about where it is, the less we can know about where it's going. And the more we know about where it's going, the less we can know about where it is. That was the part at the end of Dr. Quantum's video when he said, what does an observer have to do with any of this? Well, when you observe something with about the same amount of energy that that thing has, it messes with how it behaves, right? So it's like looking for a marble with a meter stick, right? So you find the marble, boom, but then it took off somewhere else, right? So by observing electrons, you cause them to change their behavior, right? So and if this is confusing, we can talk about this much more in depth. I'm just trying to give you a quick crash course on that. So Heisenberg said that, and Schrodinger gives us these wave equations. That's basically a big y equals mx plus b equation for where we are likely to find an electron. You're not going to have to do that gigantic equation because it's three-dimensional calculus math stuff that is awful. But the pictures that he gives us are these s, p, d, and f orbitals that we're going to look at in the packet stuff today, right? So instead of thinking about an electron like a planet zipping around the sun, that's kind of how we often draw it. We want to think about it like a cloud of space, right? A wave of probabilities where an electron, the orbitals are a place where we're likely to find an electron, but it doesn't follow a certain path. It's a wave of potentials that takes up space. It's a little weird, right? But anyway, we can talk about it more in depth. I'm just trying to give you a little bit so as you're moving forward, some of this stuff makes sense.